All right, so here's another example where the goal is to pull together all the information that we've covered in this section to graph or to sketch the graph of a rational function. I want to focus first on finding any asymptotes and the x and y intercepts for this graph. So I'll start with the asymptotes. We should work on factoring anything that we can in the numerator or in the denominator. When you have x squared plus a number like we do in the numerator, that cannot be factored any further, not with real numbers anyway. But this denominator, if we want to consider, do we have two numbers that multiply to give us -3 and add up to -2, then we could do -3 times +1. That'll work. So x minus 3 times x plus 1. It never hurts to kind of think through the multiplication to double check that we've factored correctly. So if I think through that, this would be x squared. So there we go, x squared. Plus 1x minus 3x for the outside inside when I multiply. So that would result in -2x, and then -3 times 1, that's -3. So that checks out. That's good. Now that it's factored, notice that there are no common factors in the top and bottom. I know maybe you're tempted by the x squared plus 1 and the x plus 1, but those are not common factors. The different power of x, I know it seems like such a small difference, but it's enough to make these completely different factors. So there's nothing that we can cancel, which means there are no holes in the graph, which is a good thing to note. And there will be two vertical asymptotes then. When you set each of those factors in the denominator equal to 0, those are both, since neither one cancels, those are both going to correspond to vertical asymptotes. So if you set x minus 3 equal to 0, you get x equals 3. If you set x plus 1 equal to 0, you get x equals -1. So I'm going to go ahead and draw those, or I'll put some hash marks on the axes here as well while I'm at it. I should do this before I start the video, but oh well. Okay. So vertical asymptote at x equals 3. I'm going to draw the asymptotes in gray again. So here's 3. So we've got a vertical asymptote here. And another one at -1. So that's right here. Okay. Now, non-vertical asymptotes, either slant or horizontal asymptote. This one has same degree, same highest power on the top and bottom. So when it has the same degree in the numerator and in the denominator, then you have a horizontal asymptote at y equals, and you take the ratio of the leading coefficients, which is just 1x squared over 1x squared, so it's y equals 1 over 1. So y equals 1 for a horizontal asymptote. So y equals 1, that's right here. Okay, so now we've got the asymptotes on the page. Let's talk about intercepts. So you find x-intercepts for the graph when the numerator is equal to 0. So in this case, when x squared plus 1 equals 0. But x squared plus a number, that has no real solutions, so there is no x-intercept. Okay, which is useful information. So the graph should not cross the x-axis anywhere. That's worth drawing a box around, just like this other stuff with the asymptotes. So never cross the x-axis. For y-intercept, we substitute 0 into the function f of 0. So that's 0 squared plus 1 over 0 squared minus 2 times 0 minus 3. So we end up with 1 over -3. So -1/3. So I'm just going to do the best I can. I'll draw the graph in green this time. -1/3. So that's around here. I mean, we're not trying to make it exact, just close to 0, but slightly negative. Okay. So we have that information. Now, when there are two vertical asymptotes, it does end up making a lot more work for you when you're trying to work out where exactly to sketch the graph in each region. Although the fact that there's no x-intercept is actually a pretty big clue about what the graph looks like. All right, let me also mention domain before I start sketching this. So domain is all x values except for anything that makes the denominator 0. So 3 and -1 in this case. The reason I bring up domain is to say now that we should have a graph drawn for every x value except for x equals 3 and x equals -1, which that's where these vertical asymptotes occur. So everywhere except for the vertical asymptotes, there should be some kind of curve drawn. There should be some point on the graph. So I want to start with this, I'm going to work left to right. So I'm going to start with this section from -infinity up to -1. I need to know whether the graph lies above the horizontal asymptote or below it. Now I will acknowledge the graphs do occasionally cross their horizontal asymptote. When they cross, they don't cross, they don't do anything, well, for the most part, they don't do anything drastic. I guess what I'm trying to do is avoid figuring out if this graph crosses its horizontal asymptote, but I suppose I should probably actually do that. So here, I'll pause what I was talking about here, not wimp out on that, and let's consider. So a graph can never cross its vertical asymptote, but it can cross its horizontal asymptote. So does the graph cross the horizontal asymptote at y equals 1? That's the question. So to determine whether or not, the answer to this question, yes or no, whether or not it crosses the horizontal asymptote, take your function, set it equal to the expression for your horizontal asymptote. So in this case, that's 1. So take this x squared plus 1 over x squared minus 2x minus 3. Set that equal to 1. If you get an x value for a solution here, or maybe more than one x value, that's going to tell you that yes, it does cross, and it'll tell you where. At whatever x value you get, that's where it crosses. So the first thing I would do with this equation is I want to get rid of that denominator. So I'm going to multiply both sides by the expression in the denominator. So that cancels here, and now I have x squared plus 1 equals x squared minus 2x minus 3. I see an x squared on both sides. I'm going to subtract x squared from both sides, and that's going to drop the x squareds out of this equation. So now it's 1 equals -2x minus 3. And so I could move the 3 over. So 4 equals -2x, and then divide both sides by -2. We do get a solution here. So -2 equals x. So the graph does cross, the answer here is yes, the graph does cross that horizontal asymptote when x equals -2. So if I go back up to my picture, it is going to cross this asymptote when x equals -2 right here. Okay, now to determine where exactly the graph lies, I'm going to have to plug in a couple more. Whoops, did I erase something I didn't mean to? I feel like something went away. I got to plug in a couple more x values. Okay, so how about -3? We know that it crosses the x-axis at -2. Let's see where it is when x equals -3. So if you plug -3 into this function, let me see if I can slide this up so you can see the function. And I'll erase some of this stuff. Okay, so if we plug that in, we'll have -3 squared plus 1 over -3 squared minus 2 times -3 minus 3. So that'll be 9 plus 1, so 10 in the numerator, over this will be 9 plus 6 minus 3. Oops. Minus 3. So what's that? 15 minus 3. So 10 over 12, which if you divide top and bottom by 2, that's 5 over 6. So see, it's close to 1. It doesn't go blast way past. It's going to stay, the graph's going to stay close to 1. We know it doesn't cross the x-axis because there is no x-intercept. So it's going to cross, and I know my graph is kind of ugly. It's going to cross the horizontal asymptote at -2, but it's going to stay close to that horizontal line at y equals 2. So the curve, let me try redrawing that one more time, see if I can make it a little nicer. I'm trying to erase the curve and not the asymptote. Put this asymptote back in. So it's gonna be, no, that doesn't look any better. Something like that. So it's gonna be a sort of L shape that stays above the x-axis and close to that horizontal line at y equals 1. It wouldn't be totally horizontal, even though that's kind of what this ended up looking like. But it's going to be this L shape. What I would look for in grading it is just this L shape above the horizontal asymptote. I wouldn't even blame you if you didn't have it crossing. That's a detail that I'm not holding you guys responsible for. I just wanted to show you how you could figure it out. Okay, now before I hit the time limit on this video, the middle section, because we know there's no x-intercept, I know the graph has to stay below the x-axis, so it's going to be this sort of parabola shape in the middle. If you needed to collect more clues, what you could do is plug in like x equals 1, x equals 2, and generate some y values. You're going to get negative y values, which will just further convince you, okay, I've got to have this parabola shape in the middle in order for this to stay below the x-axis. On the right side of the graph, again, it can't cross the x-axis, and it's not going to cross the asymptote either on the right side, because we only found the one solution when we set the function equal to the asymptote at 1. The only solution was x equals -2. So the graph is going to be, it has to be above the horizontal asymptote. Although, if you're not convinced by that and you want to provide more evidence to yourself, what you could do is pick an x value on the right side of this graph, so something like x equals 5, and plug that in. So if we plug in 5 to this function, you'll have 5 squared plus 1 in the numerator, and then 5 squared minus 2 times 5 minus 3 in the denominator. So that'll be 25 plus 1, 26, over 25 minus 10, so that'd be 15, minus 3, that's 12. I could simplify that, divide top and bottom by 2, that'd be 13 over 6, right? Divide top and bottom by 2. So a little bit more than 2. So when x is 5, y is a little bit more than 2. So actually not too far off from where I just kind of slap down a curve here, but that would just confirm that the graph should lie up above that horizontal asymptote at y equals 1. Now I know there's a lot going on with this graph. I think in your homework it's going to be mostly multiple choice for this kind of graph. What makes it more complicated is the fact that there's 2 vertical asymptotes. So that just means now you've got, with 2 vertical asymptotes, that means you have 3 separate sections of the graph. So you might end up having to plug in x values in each section of the graph just to confirm, okay, what's the y value, and that'll give you a clue about what's going on with the graph or where the graph should lie.